Okay, 3.7 is graphing absolute value functions. Okay, so here's an absolute value function. This is the most basic absolute value function you could have. There's nothing added or subtracted or multiplied. So we've got f of x equals the absolute value of x. Now, if you've never graphed a particular type of function before, or if you just forget how, a good strategy to begin with might be to make an xy table. I don't have a y in this equation. I have f of x instead, so I'm actually going to make an f of x table instead of an xy table. So what I'm going to do for my x's is choose any numbers I want. So I'm just going to choose some convenient numbers. I'm going to choose those for x, and I'm going to plug those into the equation and see what y's or f of x's I get out with them. Okay, so when I'm finding, I'll just do this down here, f of 0, that means that's the absolute value of 0, right? I'm just plugging 0 in for x in both those slots, and the absolute value of 0 is 0. So when I plug in a 0 in for x, f of x equals 0. Okay, and I can do the same kind of thing with the rest of these. I'm really just taking the absolute value of those x values, so I'm not going to write them all out, but the absolute value of 1 would be 1, and the absolute value of 2 would be 2. Okay, so now I know 0, 0 is on my graph, 1, 1 is on my graph, 2, 2 is on my graph. Kind of looks like it's going to be a straight line, but it's actually not. Let's see what is going to happen when we plug in some negative values. Okay, so I'll do this one down here. F of negative 1, that means the absolute value of negative 1. So how far away from 0 on the number line is negative 1? Well, that's 1 unit away, right? Because those distances are always positive. So the absolute value of negative 1 is 1. The absolute value of negative 2 would be 2. So then I've got points going like this, and I'm actually going to end up with a V shape for absolute value functions. Something like this, okay? All right, so let's see what happens with this one. And we'll get to a point where we don't need the xy tables anymore, but it's just a good place to start. So when I plug in 0 here, I'm just going to do this in my head. I'd have the absolute value of 0, which is 0, plus 2. Okay, so that's 2. When I plug in 1, I'll have the absolute value of 1 plus 2, so that'd be 1 plus 2 is 3. Okay, so I get 0, 2, 1, 3. Kind of running out of space up here. I'm at the top of my graph, so let's see what happens when I plug in some negatives. I'll have the absolute value of negative 1, which is positive 1, plus 2. Positive 1 plus 2 is 3. Okay, and that's that point right there. And now I know what the V is going to look like. So the key on these problems is to find the vertex, right? This would be the vertex. It's just the corner of the V. So that vertex is 0, 0. This vertex is going to be the point 0, 2. And once you find that, then you can figure out where the rest of the points are going to go. And you can keep plotting more points. It just keep going up in both directions like that if you wanted to. Okay. So let's look for a little pattern here. So when we added 2 to the function, it moved the whole V up 2 units, right? So this is going to shift everything up 2. So it's a translation up 2. I'm just going to write up 2 here. So that's good to know. If you add or subtract something from the end of absolute value, it's going to just move it up or down. So if I had a minus 7, it would move my whole V from this down 7 units. Okay, I'm going to call this the parent graph because that's our basic graph, and then we can, when we mess with the equation, we can just think about, well, what would that do to the parent graph to our basic absolute value function. Okay, so these look pretty similar. I have a plus 2, but you notice the plus 2 is inside the absolute value, and that's it means it's not gonna just shift it up 2. So let's take a look at this one. I really need to find the vertex. That's the key. So let's start plugging some values in. When I plug in 0, I'll have 0 plus 2 inside there, so the absolute value of 2 is 2. All right, so 0, 2. When I plug in 1, I'm going to have the absolute value of 3, which is 3. So far, it looks like just like the last one. But let's see what happens when we go to the left. Now, if you put the negative 1 in there, we'd have the absolute value of 1, which is 1. So negative 1, 1 is right there. So now you can see, okay, that's not quite the same. So let's keep going here. If I plug a negative 2 in, I'd have the absolute value of 0, which is 0. And I really want to find the corner, so I want to keep going until I turn the corner there, until I find the vertex. Alright, so now I'd have if I plug a negative 3 in, absolute value of negative 1, which is positive 1. And hey, now I found the corner. Okay. Okay. So if you look at this vertex, it's the point negative 2, 0. So when you're adding and subtracting inside the absolute value, it's going to move your v left or right, and it's a little bit counterintuitive. You might think plus 2, okay, I'll go to the right, but it's actually going left 2. Okay, so what you want to do is take the contents of the absolute value. If you set that equal to 0, and then solved it for x, then that's moving left 2, right? So that's going to be the general strategy. So now let's not do an xy table on this next problem. Let's just try to use these patterns. So when I'm adding and subtracting inside, that's going to move things left or right. So my advice is take the contents of the absolute value and set it equal to 0. And so this is telling me, okay, I'm going to go 3 to the right. That's going to be the x coordinate of my vertex, and my y coordinate is just whatever is added or subtracted to the end. So the vertex then is going to be the point 3, 1. Okay, so 3, 1 is right here, and then it just follows the pattern of all these other ones. So from there I'd go up 1 to the left 1 and up 1 to the right 1. Ran out of space on my graph there, but that's where it would be, right? And you could keep going there, and there is my absolute value function. Okay, a lot quicker than making an XY table once you know what to do. Okay, now all the ones we've looked at so far will open upwards, but we can have ones that will open down. So let me just cut to the chase here. So when you see that we've got negatives on both of these. So when you have the negative inside the absolute value function, multiplying the x, it's like multiplying the input, that's going to reflect over the y-axis. Okay, so let's think about what the parent graph looks like. So the parent graph, I'm just going to put my points in. And then I'm going to think, well, what would that look like if I reflected that v over the y-axis? Okay, so there's the y-axis. If I'm reflecting over the y-axis, that's going to happen. So if you think about reflecting this point over the y-axis, well, it's 1 unit away from the y-axis, so I'd go over there. It would end up right there. This point would end up there. So this is going to reflect onto itself. That point's already on the y-axis, so it just stays there. So it's not very exciting reflecting absolute value functions over the y-axis because it looks the same if it's centered on the y-axis at least. Okay, when we've got the negative outside, that's going to reflect over the x-axis. Okay, so I'm just going to put the little points for the parent graph first. Okay, there's nothing added or subtracted to these, so the vertex is still going to be 0, 0. Okay, I know that. But let's think about reflecting over the x-axis now. Okay, so if I take this point, for example, it's 2 units above the x-axis, so I go straight down to the x-axis and go 2 units out the other side. That would be a reflection of that point over the x-axis. This one's 1 unit above, so I'll go 1 below, and then the same thing happens on the other side. So when we reflect over the x-axis, that means it's going to open down. Okay, and that is super important. Okay. Okay, on the next page we're going to look at some examples that have reflections and translations where the vertex is going to get moved from these numbers, and that's going to give me a reflection. Okay, so my advice on these is to when graphing absolute value functions, find the vertex before doing any reflections. So I'm going to say find the vertex before reflecting. Okay. All right. So yes, I do have a reflection over the y-axis because of that negative. But the way that I approach these problems, all you really need to know is if this opens up or down. And since it's going to be reflecting over the y-axis, it's still going to open upwards. So that's all I really need to look out for that. The vertex is going to be reflected, which means all the other points will too. But if you just take the whole contents of the absolute value function and set that equal to 0, including the negative, set that equal to 0, then that will take care of the reflection, and I won't have to worry about that because the negative is going to affect what this x value is. Okay, so I'm going to subtract 2 from both sides to solve for x. So that means negative x will equal negative 2, but I want positive x, so I'm going to multiply or divide by negative 1 here, and then x equals 2. Okay, so that's the x coordinate then of my vertex. My y coordinate is just that number. So my vertex then is going to be the point 2, 1. Okay, so I like to find that first and get that locked into place. So 2, 1 is right here because that's not going to move. Okay, and then I'm thinking, okay, I know this one opens upwards because it didn't reflect over the x-axis, right? So then I just follow the parent graph pattern. So from here I go up 1 to the right one, and up 1 to the left one. I could go up 1 to the left one again. I guess I could go up 1 to the right one again. And then we've got our function right there. Okay. All right, let's try another one. So this one has that negative in a different spot. And then so this is going to open down. That is important to recognize. This is going to be a reflection over the x-axis, which is going to take my v and flip it upside down, right? Okay, I'm still going to find the vertex in the same way I did on the last problem. So I'm going to take this and set it equal to 0, and then all I have to do is subtract 1 from both sides. Okay, and then my y is going to be negative 3, so my vertex is negative 1, negative 3. Okay, negative 1, negative 3. I'm plotting that. That's not going to move. That's not going to get reflected. But I know this opens down. So normally I'd go, up 1 to the right one, up 1 to the left one. Well, since it opens down, that means I'm going to go the other direction. And I should have made this graph bigger. So I'm going to make a couple more points down there. Okay, so I'm going to go down 1 to the right one, down 1 to the left one, and repeat that. Down 1 to the right one, down 1 to the left one. Okay, so this parabola now opens downwards. Okay. So far, all of the problems I've shown you, the V's are the same width, but we can change how wide or narrow the V is by multiplying the equations by something, and that's what I'm going to show you on the next page. Okay, on the next page we're going to look at some stretches and shrinks. This is a little hard to see at the top of this page, but a stretch or a shrink is going to make the V either look wider or narrower. Okay, and on this side, when we've got y equals 2 times the absolute value of x, and when we have y equals absolute value of 2x. When that number is more than 1, then what's going to happen is it's going to look narrower than the original. So this one that I'm highlighting now, this is this one, okay, and then this one would look like that compared to the parent graph. So you notice both of them are going to look narrow compared to the parent graph. That's not a technical term, and that's a little bit of an oversimplification because one of these is going to be a horizontal shrink and the other one's a vertical stretch, and it does matter which is which, okay? But it is worthwhile to know that if you have a number more than 1, the V is going to get narrower. If you have a number less than 1, then it's going to get wider. So this is what that one would look like. And this is going to look like that. So they both get wider. They actually look the same, but the way they got like that is different. One of them is a horizontal stretch. The other is a vertical shrink. So these ones are going to look wide compared to the parent graph. Okay. All right. So there's a lot to keep track of with these stretches and compressions. It works in the same way it does with linear functions. So the previous video, I've got a chart that's very similar to this. But yeah, let's look at this again. Okay. So yeah, when we're multiplying by a number like we are in these, that's going to change the width of the V. Okay. But that can happen in 4 different ways. So you can have a horizontal stretch or shrink, and you could have a vertical stretch or shrink. Okay. So when the A value in these bottom left corners, that's going to be what is in the equation, either a 2. So my A here, value here is 1/2. Here the A value is 2, and so forth. Okay. What is going to make it a horizontal change as opposed to a vertical is the placement of the A value. So we're multiplying the input by a number on both of these, and that's what makes it horizontal. Where here we're multiplying the output, the numbers on the outside of it's 2 times f of x and 1/2 times f of x, right? As opposed to these where we're multiplying the inputs by the number, okay? All right, so it's when we're looking at this one, this top left one, since it's a horizontal change, that means it's a horizontal stretch. Well, that means that these points are going to move horizontally, okay? And they're going to be stretching. So they're going to stretch when we're doing a horizontal change. Those points are going to move away from the y-axis, okay? And down below, with our shrink, they'll move towards the y-axis. So I'm just highlighting what those are moving to or away from. All right. So with our stretch, these points are all going to move out. Okay, and now since the factor is 2, which by the way is the reciprocal of 1/2, that means I'm going to double the horizontal distance. So I can see this first set of points is 2 units away from the y-axis, so I want to double that. So this new point D, I'm going to label that D prime with a little tick there, would be there, right? Now it's 4 units away from the y-axis as opposed to 2. Same thing's going to happen over here with the A prime. And those bottom points are just 1 unit away from the y-axis, so I double that. And here would be C prime, and then B prime would be out here. Okay, the ticks were a little, the graph printed out a little light, so I'm just going to put in the ticks on the axes. Okay, but then when we draw this in, here's the graph of of f of 1/2 of x. Okay, so when we're going in, my factor here is 1/2, so that's what you'd be multiplying those horizontal distances by. So it'd be multiplying the x values because that controls the horizontal distance. So I'm going to take, these are going to be half the distance that, my new points are going to be half the distance, so that would be my new point C. So now those are going to be both half a unit away from the y-axis. Okay, and the top points are right now 2 units away, so I want to take half of that and make them 1 unit away. I won't label those points, but that's what they would look like. And so we're going to get something that looks like that. Okay, so those points are going to move in towards that axis. Okay, all right, let's look at the vertical ones. So on the vertical ones, that means my points are going to move either up or down, which means they're going to be moving towards the x-axis or away from the x-axis. So I'm just highlighting the axis that they're moving in relation to. Okay, so a vertical stretch, so that means these are going to move up and away. So my factor here is going to be 2. That means I'm going to double the height of these points. Okay, so I'm looking at this first point is 1 unit above the y-axis. So I'm going to double that, so now it's 2 units above the y-axis. Okay, and same thing here. And these points are 2 units above, so I double that to make the new ones 4 units above. Okay, and then I can draw in my new v. All right. These ones, I'm going to take half of the height. It's really multiplying the y coordinates by 1/2, and that's going to give me a v that's wider because all these points are going to move down towards the floor, towards the x-axis. So I'm going to take half of that height, I'm going to take half of this height, and the same thing on the other side. Okay, so yeah, a lot to process, but at least we got it all in one chart here. And you know, I'm using 2 1/2, but if we did 3, then my factor would be 3, and I would triple the height of those points or whatever, right? Okay. All right, let's try some examples on the next page. Okay, so we've got, let's look at the equation side of things first. Not going to do any graphing on this page. So vertical changes is when we're multiplying the output. So this a value, we're going to be multiplying the whole function, we're all of f of x by something. Where with the horizontal changes, we're just multiplying the input, right? Okay, and then you can tell if it's a stretch or shrink based on the value of a. So with our vertical changes, if a is going to be between 0 and 1, so a number less than 1, then we've got a shrink, and if it's a number more than 1, we've got a stretch. Okay, and that kind of flips around on the other side. With the horizontal one, the shrinks are going to be when a is greater than 1, and the stretches are when it's less than 1. So it's a little confusing. Also, notice the factor is the same as a with the vertical ones, but it's the reciprocal when we're doing the horizontal ones. Okay, so I've got this split into 2 columns. So let's just start with the vertical changes. So I'm going to write a function g. So I'm going to call my new function g of x. And it says it's going to be a vertical stretch of f of x by a factor of 5. So the factor is just the a value. So that means up here, this a value is going to be 5. So I'm going to take 5 times f of x. Okay. Now what I'm going to do, so this is going to be my new function g. I'm going to have to multiply f of x by 5. Well, I'm going to substitute in where it says f of x. Okay, because right above I can see f of x is equivalent to all of this. Okay, so I'm going to substitute in, and it's really important to use parentheses when you do this. So this is going to be absolute value of x minus 2 plus 3. Right, I just substituted that in where the f of x was. I need the parentheses because I'm going to have to distribute this 5. And there's a lot of mistakes that get made with the distributing. Some people just forget to distribute altogether and just leave it like this without the parentheses. But what you want to do is distribute it like this. Okay? So that gives me 5 times the absolute value of x minus 2 plus 15. Okay? Now, the other mistake that gets made, people will distribute into the absolute value, but you can't do that. It doesn't work like regular parentheses. So there's nothing else we can do with this. So that would be the same as doing a vertical stretch by a factor of 5 on f of x. Okay? All right. So when we're doing a vertical shrink here, we're going to use the same kind of strategy. So this is going to be my a value, so I'm going to take 1/2 times f of x. And again, just like the last problem, now I'm going to substitute in for f of x. I'm going to substitute in all of this, and I'm going to use parentheses when I do that to help remind me that I'm going to need to distribute. Okay. So here, let's distribute the 1/2. One of them is going to go there, but then also we're going to multiply the negative 5 by 1/2. Okay, and then I'm thinking 1/2 times negative 5, well, it'll come out negative because a positive times a negative. And you can think of this as 5 over 1. And then 1/2 times 5 over 1 would be 5 over 2. Or you could say negative 2.5, that would work too. Okay, and then there's nothing else that we can do there. Okay. All right, let's try the horizontal one. So now our a value is in the input. Okay. All right, this says write g of x for a horizontal stretch by a factor of 3. Now this is a little tricky here. this is the a value, but then sorry, that's not my a value, that's my factor. Sorry, factor equals 3, but the a value is the going to be the reciprocal. So that means a is going to equal 1/3 actually. Okay, so that's the number I'm going to use for a up there. Okay, so looking at this, I've got f of 1/3 times x. Okay, I often see people just do f of 3 of x, and I get that because it's confusing, because that's what we would have done if it was a vertical change. But with the horizontal ones, you have to use the reciprocal. So you flip this fraction upside down. It's not a fraction, but you could write it as 3/1, and then the reciprocal would be 1/3. Okay, and now what I'm going to do with this one is I'm going to input this into function f. So this is f of x. If I want f of 1/3 x, well then I've just got to replace the input with 1/3 x. So I'm going to replace that x with 1/3 x. All right. So that means g of x, I'm going to take 1/3 x, still got the plus 3 and the minus 7 out there, an absolute value, and there's nothing else that I can do. I can't simplify any further than that, really. So really you're just replacing the x with a 1/3 x, all right? And on this next one, if my factor is 3/5, well that means I'm going to take the reciprocal of that 5/3, okay? So g of x then is going to equal f of 3/5 times x, or just 3/5 x, okay? And here then I'm going to input this in for x into function f, okay? So I'm replacing the x with 3/5 x, and then there's nothing else I can do to simplify that. Okay. All right, and then let's do some graphing that involves stretches and shrinks. So this is a little challenging, especially when it's new to you, when you haven't had experience with it. If you have that chart in front of you from the notes, that's great, but of course we're not always going to have that in front of us. So this is what my method for doing this. First thing I would do is find and plot the vertex. Okay, so I'll go through these steps as I'm talking about the different steps here. So finding the vertex here, I'm going to take, some people say, oh, it's going to be -3, -2, because they just changed the sign of this, but that's not quite correct. You have to take everything that's inside the absolute value and set it equal to 0, okay? Then I'm going to solve this equation, and that's going to give me my x value. So the 1/2 is going to affect the x value here, okay? So I want to get x by itself. I'll start by subtracting 3 from both sides. Okay, and then I still want to get x by itself. So what I'm going to do here is multiply both sides by 2, because 1/2 times 2 is just 1, and then I'd end up with just x on the left side. Now I've got x equals -6, because those cancel each other, right? Okay, so that's my x coordinate. My y coordinate is whatever is added or subtracted to the end. If there's nothing added or subtracted to the end, then your y coordinate would be 0, but here it's -2. So my vertex is going to be -6, -2, okay? And I'm going to go ahead and plot that on the graph. -6, -2 is right here, okay? Once you get the vertex in place, there's my vertex, I'll put a little v for it. It's not going to move with any stretches or reflections or shrinks or anything like that, okay? All right, so step 1 is complete. Step 2, I'm going to lightly graph the what I call the ghost. It's just something I made up. So what that is, the ghost, is it's my parent graph, but opening from this vertex, okay? So the ghost, that's without stretches or shrinks. but I would include any reflections. So the only thing I'm really looking for on the reflections is if it's opening downwards. This one's not opening downwards because I don't have a negative in front of the absolute value. Okay, so it's going to open upwards. So my ghost is just I'm going to kind of just ignore the 1/2. That's going to cause a stretch or a shrink. But if that wasn't there, then I'd just be going up one to the right one, up one to the right one from the vertex, and I'll go up one to the left one, up one to the left one. So that's my ghost, okay? So I often just plot the points. You could do little dashed lines or draw it lightly with pencil or something like that. We're not finished with this yet, but it helps to have these points in place because the vertex stays put and we're going to do the stretch or shrink on the other points. Okay, so these points are going to move with a stretch or a shrink. Okay. So the hardest part of this is to move those and get them in the right spot. So my last step here is going to be graph the 5 critical points. And by the critical points, I mean you'll need the vertex for sure. And then I like my students to do 2 more sets of points. Sometimes you might not have room for that on the provided graph and just fit as many as you can. But so here, if I get these moved correctly, I'll have my 5 critical points, okay? But now I'm seeing that I do have this 1/2 I have to deal with, okay? So I'm not going to use that chart. Here's how I think of it. I think, okay, if this is a number more than 1, it makes it narrower. If it's less than 1, it's going to make it wider. So I know that my graph my V is going to end up looking wider than this original function, okay? Then my ghost, I mean, all right? Now, that's not a technical term. You could just kind of draw in a wider one, but you'd want to get it correct. You want to move those points in the correct way because there's 2 different ways to get a wider V. All right, so then I'm thinking, well, is this a horizontal change or a vertical change? And that depends on the placement. So you see how the 1/2 is multiplying the x directly. Well, I think of the x-axis as the horizontal axis, right? So since that 1/2 is touching the x, that means I know I've got a horizontal change. Okay, and then the trickiest part of this that I spent a lot of time trying to explain, I need to figure out now if it's a stretch or shrink, and what I'm going to do is put these 2 things together. So my vertex is staying put. With a horizontal movement, that means these points can only move left or right. Okay? So I'm thinking, well, which way would give me a wider V? If I move them in, my V is going to look narrower, right? So I'm going to have to move them out. And then I'm looking at this and thinking, okay, since this is 1/2, I'm going to actually do my A value is going to be 2. So I'm going to double the width of this. And even if you didn't remember that it's the reciprocal, we know it's going to be wider, and since it's a 1/2, that means it's getting twice as wide. If it was 1/3, it'd get 3 times as wide. Okay, so looking at those 2 bottom points, they're 1 unit away from the middle of the V, so I want to double that and put them right here and here. So those points are moving out. Okay, and then, so here's the center of my V, right? I'm just kind of lightly doing this, just for visualization purposes. So this is 2 units horizontally from the middle of the V, so I want to double that and make it 4 units. Okay, and the same thing on the other side. And now we've got our V. Oh, in the notes up here, I sometimes use the word compressing. Some of the books do that instead of shrink, but that's the same thing as a shrink. Compress just means like press together, right? Like that. Okay. All right, so let's try another. It takes a lot of explaining for me, but once you get the hang of it, these problems aren't actually that long. So first step here, I would look for the vertex. Okay, I solved that by subtracting 2 from both sides, and then this is going to be my y-coordinate. So my vertex is going to be -2, -1. Okay, so let's go ahead and plot that. -2, -1. Just fits on the provided graph there. I'll just put a little V to remind myself not to move that with any stretch or compression. Okay, then I'm going to do the ghost. So I know this is going to open upwards because I don't have a negative in front of the absolute value. So my ghost, I'm just going to go up one to the right one, up one to the right one, up one to the left one, up one to the left one. Okay? And then the hardest part is I have to deal with this 3. So I'm thinking, okay, does that make it wider or narrower? So since it's a number more than 1, you got to just remember that when you have a number more than 1, it makes it narrow. If it's a number less than 1, like the previous problem, then it makes it wider. Okay? Now I'm looking at the placement of the 3. So I'm thinking, is it touching the x directly? It's not. So if it were inside touching the x, it'd be a horizontal change. Since it's not, this is going to be a vertical change. Okay? And then my last part is thinking, okay, these points are going to move vertically. That means they're going to move only up or down. And I'm kind of just visualizing, well, if I need a narrow parabola, if I move these down, these points down, my v would get kind of smushed like this, and it's going to look wider. If I move them up, then my v would kind of stretch and look narrower, right? So if I move these up, I will end up with a narrower v. That's what I want. So these are going to stretch then away from the vertex. So this is a vertical stretch. Okay? And the factor is going to be 3. So this means it's going to get 3 times the height of these points is going to multiply by 3. Okay? So I'm looking at the height of that point and the height of this point. Same thing over here and here. So this is 1 unit above the vertex. So let's triple that. So I don't want to go 3 units up from the point. I want to go 3 units up from the vertex. So 1, 2, 3. So it's another 2 units from where it is, but it's a height of 3 units. This one's 2 units above the vertex. I want to triple that. So that would be 2 times 3 would be 6, right? So from down here, 1, 2, 3, 4, 5, 6. Just fits on the provided graph. And then the same thing happens on the other side. And now I've got my v. Okay, so yeah, there's a lot to digest on these problems. It takes some practice. It's one of the more difficult topics in the book. All right, that's it for this video, and I'll see you next time.